My name is Ravi. I'm a senior managing consultant at Altis. I'm part of Altida product team, and today I'm going to demonstrate how easy it is to ingest the data from data sources like files, RDBMS, or even APIs using Altida and Snowflake. So, can you guys see my screen?
Uh, Yeah.
So in this particular demo, we'll focus on ingesting the data from an S3 bucket, in particular the CSV files. Okay, and the same principle gets applied to other data sources like RDBMS and APIs. Yep. So here is the task. So as a data engineer, I have been given a task to ingest the data from an S3 bucket. So I have this S3 bucket, and I have like a whole bunch of CSV files, JPEGs, or whatnot. Okay. My task is to only ingest the data which start with the file name sample_CSV. So there are two of them. Okay. And to achieve this task with Altida and Snowflake, these are the steps involved in delivering this task. Step one is to create an extract meta definition. This is as simple as inserting a record into our extract meta table. Yep. So once that is done, we'll clone the OpenFlow CSV pipeline. Okay, so this pipeline is pre-built and delivered by Altida product team. Okay, so all you need to do is just clone that OpenFlow CSV pipeline, update one of the parameters, and run it. Okay, as simple as these three steps, and we're going to see this in action. Yep. So let me switch back to Snowside. Okay, and what I'm going to do is as I'm delivering this task, I also want to put my code in the source control so that I'm not working in isolation. Okay. So when my code and everything is tested in the dev environment, I'll just push the changes into the GitHub repository, and we can release them into the higher environments like SID, UAT, prepod, and prod. Okay. So by this, we get to see the Snowflake native Git integration pattern as well. Yep. Okay. So step one is I have attached I have connected my Snowside workspace to the GitHub repository, okay, which is hosting Altida code, okay. And what I'm going to do now is because I'm working on a new source, so this is a CSV source. So in reality, this can be like Salesforce or any CRM system, but in this particular case, I'm just going to call that source as a demo_CSV. So I've created a separate folder for that under extract meta, because it's good to track any changes that you make to that extract meta, using this particular folder, because it's very easy to pick up those changes. Okay, so under this folder, I have just created this SQL file. It's a blank SQL file, and it says create demo CSV extract meta. So the question is, how are we going to generate that extract meta entry? So in this case, I'm going to use the cortex code skills file, okay, because the cortex code, we have created a skill for the cortex code to understand our Altida tables. So it knows about the structure, it knows what we want and how to generate the entries. So I'm going to use that skill file to generate an extract meta entry. Okay. So let me give the prompt. So I'm just going to copy and paste this prompt to cortex code skill set. By the way, we have also integrated the skills file into the GitHub repository so that anyone who pulls this repository, they get to see the skills file. Yep. Okay. So because in our Snowflake environment, there are multiple Altida databases. The first step is the cortex code will ask you which database does this table live in. So I'm going to say create an entry for extract meta in this database. So it's going to use that database as a context. So what it has done is it has analyzed the structure of the extract meta table to pull out all the metadata, the columns, and the data types. And now it has asked me the question. So it already knows that I have asked for a truncate-and-load template for the CSV file. Okay. Now it's asking me what delimiter does your CSV file use. So in this case, my CSV uses a comma delimiter. So I'm just going to specify it's a comma-based delimiter.
Can you show the first prompt that you wrote, what you asked for? You just read it out. So yeah, so can you please create an Altida insert template for truncate and load pattern for a CSV file?
Yeah.
So it knows it's a truncate and load.
It's a truncate and load pattern. Yeah. So if I hadn't specified the truncate and load pattern, you would have seen another additional prompt asking you to pick one of the load patterns, whether it's truncate and load or append or CDC, delta or merge, whatever load patterns that we have defined in Altida. Because we have specified truncate and load, yeah, it just bypassed that step in the workflow. It's smart enough. Yeah. Okay, so it has created this insert template for me. I'm just going to copy the template go in here and paste it. Okay. So as you can see, the template has already been pre-configured. These are the bare minimum values that we need to set, okay, to create that extract meta. So I can say something like demo_CSV. So rather than me typing all these placeholder values, so I've already filled those placeholder values. So let me copy that. Okay, see here. So I've substituted those placeholder values with the real values. So I call demo_CSV as a source name, CSV as a source type. The object name is sample_CSV because out of these files, 4 files in that S3 bucket, we only want to process these 2 files. So I have used a regular expression percentile, the wildcard character at the end, and it's a truncate-and-load pattern. So which means load type is append with a SQL statement 1 = 1, and this is the first level folder in my root S3 bucket. That's pretty much it. Like,
yeah. And so the table stage table names, the table names.
Stage table, yeah.
So what we're saying, to dump the data into
exactly. Yeah. So this will be the landing schema. The landing view will be created in this schema, and then and then from there we're going to merge the data into this stage table name, which sits in that schema. Yeah. So the final output will be in stage table.product_w. That's pretty much it. So once this is done, because it's a dev environment, I'm just going to execute this directly. But whereas in the higher environments like SIT or UAT, you would release that to the release pipeline. You don't execute the code directly in the dev environment, in those environments. Okay, so in dev environment, the entry has been created. So step 1 is done. Okay, now that's what you need to do from Snowflake side. So step 2 is to go to OpenFlow. Okay. Sometimes view canvas. So in OpenFlow, Altida team has already created OpenFlow templates for those 3 data sources. So you have a template for file, template for RDBMS, and template for API. Okay, and even within those 2, even with those templates, we have 2 types, 2 subcategories. One is the internal stage template and external stage template. So what that means is, if you want to build up your data lake completely in Snowflake stage, you can use these internal stage templates. Okay, but in this case, I'm going to pick up the external stage template. So what this one does is it will connect to the source, ingest those files, and lands them into a folder within the S3 bucket. And from there, Altida will pick it up and push the files into and push the data into the Snowflake stage table. So I'm gonna go with the CSV template for S3. All you need to do is just clone the template, right-click on the parameters, and change the source name to whatever source name that we have configured in the extract meta, which is demo_CSV. I think it's already done. Okay, I'm just going to do that again. Back to process group. Yeah, that's all you need to do from the template perspective. It's all good to go. We just go and run the pipeline. Okay. So what this OpenFlow template is doing is it's connecting to the Snowflake, reading out that extract meta entry for the source that we have defined, pulling out all the instructions, then connecting to the S3 source folder, picking up those CSV files, landing them into the S3 stage for the DLA to pick it up, and then it's going to put the data into the stage tables using the pattern that we have defined. So that's all happening right now. Okay, so while the pipeline is running, I'm just going to go to the Snow side to see what's going on behind the scenes. So if I query the extract run queue, if I query the extract run queue, so you can see that 2 run plans have been created, and mainly because of the fact that we have 2 CSV files in that S3 bucket. So it created a run plan for each of those S3 files, and it's processing those S3 files at the moment. Yep, it's going to take a while. Like within a minute, you should see those 2 files being ingested. So while this is running, let me query the extract meta table. Okay, so as you can see, we have processed a whole bunch of data sources like RDBMS, REST APIs, and even the complicated APIs like Graph, which has got that complicated pagination pattern. Everything is been done using OpenFlow and Altida. Okay.
Image analysis.
And also the image analytics, where you can analyze the images using Altida, Cortex AI, and the Snowflake. Yeah. Okay, so I've just queried the run queue. All the plans have disappeared. So what that means is the data has been ingested. So a plan will disappear from the run queue for a plan to disappear, only two things can happen. One is either the job has been, if a plan stays in the run queue even after the pipeline is run, that means there is an issue with the job. There's an issue with the pipeline run. If it has disappeared, that means the job has run successfully. Okay. So let me go and query the stage table. Okay, as you can see, 941, the UTC timestamp a minute ago, and you have 699 records ingested into the stage table. Okay. And if you want to see what has happened with the logs, what Altida had done behind the scenes, you can query this historical log table. It's a view. And then you get to see all the run plans that have been processed in the past. So if there was an error, you can just use this view to get the reason for that. Altida captures the reason for that error, and you can just debug that way.
Yeah, also show the housekeeping columns in the stage table, about how they are created.
Yep. So these are all the standard columns from the source. Apart from that, Altida also creates these housekeeping columns like ETL. Anything to do with the ETL underscore, they are the housekeeping columns created by the Altida.
And as part of the schema management, all the columns are automatically picked up from the CSV file. So you go on the other side, we didn't have to define any column names or anything in the metadata anywhere. It automatically derives that from the CSV file. And there could be patterns where there are no headers. In that scenario, you can either define your own columns or it will land it with artificial columns. So you can manage load CSV files, or CSV file is just a nomenclature. It could be any kind of delimiter. It could be caret, it could be tilde, it could be any kind of delimiter. And any kind of file too. It could be a JSON, Avro, Parquet, doesn't matter.
Yeah. So as you can see, like this stage table didn't exist earlier. So the entire schema management is completely done by Altida. And if the source is changing and you want to handle the schema drift, that can be done with just one configuration change. You go and define the schema drift code in the extract meta, and then Altida will take care of the schema drift for you.
Yeah. Now deploy.
Now, deployment. Okay. So now I have tested my extract meta. Like, I have run the pipeline, data came through my stage table. This is good to go. My task is done. So the next step is like, how are you going to push this task into the higher environments, right? So as you can see, when I added this, when I updated this file to include my merge entry, Snowflake knows that there is one change, okay? Because this file has been altered. All you have to do is push that to commit your change. So added an extract meta entry for demo and just go to CSV source. Push. So this is actually committing the change and pushing those changes into the remote repository. Yeah, the push is done. So we're going to go to the GitHub repo, and you can see there is a recent push 2 seconds ago. Okay, and that's sitting in my feature branch. So to deploy this into the higher environment, I just have to raise a pull request. So pull request from feature into dev, create a pull request. So ideally you can secure it, you can assign the reviewer, but for demonstration purposes, I'm not picking any reviewer. I'm just going to create the pull request.
Here dev is the main branch.
Yep. And then I'm gonna, once I merge the pull request, confirm and merge. So this is going to trigger an automated CI/CD pipeline. Okay. So when I go to the GitHub Actions, so you can see the pipeline has already been queued. A request has already been queued, and this will go and deploy the change to the dev environment. And then you follow the same process from the pipeline
against the test environment, not dev environment.
Yeah, so sorry, test environment. Yeah. And once you run the pipeline in the test environment, it's good to go. You follow the same process. Create a pull request from test into UAT or pre-prod, and then merge the pull request. Yeah.
Yeah, that's it.
That's pretty much it. And this is the workflow file that has been created, which does all that CI/CD operations for you.